So the next device is wireless access point. Now these devices, these next two devices are, we also say these devices as gateway devices. These devices are also called gateway devices. Mostly these devices sit on the gate of your network, internal network, and they connect your internal network to external network. Now the first device there is what? Wireless access point, AP. In short, we say AP. This wireless access point allows the mobile users or wireless devices to connect to a wired network without physical wire link via radio frequencies technologies. A wireless access point AP is a data link layer device that contains both a transceiver for wireless communication and a jack for connection to a LAN using twisted pair or fiber optic cable. That means it sits on the middle of the wired network and the wireless network if you want in your local area. So it connect, on one side it connect the wired network, and the other side it will give you the wireless network for your mobile devices. Mobile devices means the devices which you can move easily. It is not just like a mobile, it is like laptops and other devices also, which is handheld devices which you can move around. So those devices comes with the wireless receiver. So this AP is also it is also transceiver for wireless communication and also jack for the connection of LAN using the twisted pair or fiber optic cable. So after you connect the WAN access point, wireless access point to a cable network, wireless devices within the range of the wireless access point's transceiver can communicate with systems on the cable network. That means in one side you connect the cable network, and from the other side it gives the wireless communication to wireless devices. So when you connect this, then your wireless devices can communicate through this AP to the wired network. Now wired network, it can be another LAN or it can be a internet. So mostly we use it for internet. Now can communicate with the other system cable network using the wireless access point as a conduit. The result is that the wireless devices functions as though they are part of the cable network. A hotspot is a common public application of APs where wireless clients can connect to the internet without regard for the particular network to which they have attached for the moment. So when we enable the wireless hotspot in our mobile also, this is also, that also works like a, that also work like a wireless AP. So mostly when you want to have a internet, wireless internet in your house or in your small office or small LAN, then you can use this wireless AP. So in one side you connect the internet from the port, and the other side it gives you the wireless communication to your wireless devices. Why we use wireless network? Because it is easy to set up, easy to move, and we can say it is cheaper than the LAN network, normal wired network, because we don't have to set up devices with the wired, and it can be easily moved and redesign very easily. If you're setting the wired network, then it is not easy to redesign it or move it from one place to other place. This one is easy to do that. But the problem for the wireless network and wireless APs, that security. Security is the problem because it works like a hub topology, bus topology. Why? Because this wireless APs, they work like a hub because they don't have any directional wired connected. So the communication is unidirectional. That means they are not guided because they are not wire. There is no wire for the communication to the devices. So the communication with the devices is unguided. and unguided means it will send the data to everywhere. So if the device is in this side, in your right side of the router, but the data will go, the communication will also go to the left side, right side, up, down, everywhere. So if someone is sitting on the other side and it is wanted to have that data, they can easily get without doing anything. So because of that, it is having a little problem of security. So this APs, we also call this as a wireless router. Why we call it wireless router? Because it do some of the job of some of the job of router, and that is why we call them as a wireless router. But the actual name for these wireless devices are wireless access point, WAP, or we can say AP. Now, why they call router? Because they do connect to different networks, and that is the job of routers. Routers, these wireless routers, or we can say wireless APs, they are for small offices, small network. But these routers, these are typically these are typically for the big network, or depending on the router, you can get the small router also. So these routers connect two or more logically separated networks. That means these routers are designed to connect two separate networks, logically divided networks. Now, when we say logically separated networks, that means with the IP network. We will see the IP addressing also. We have seen it already, but we will see it again because it is important to understand. So when we configure the IP addresses, these addresses are called logical addresses. Physical addresses are MAC addresses, which we cannot change. Logical addresses we can change, we can configure as we want and what we want. Now those addresses have networks, and we will see that again. So these having those network those IP addresses have a network part. So if two IP addresses you have in two devices, if their network parts are same, then they will consider as a same network. But if their network part is different, then we say that these two networks are not same network, they are separated two networks. Now, when you are having two devices with the same network, that means they are sharing the same network part, IP address of the same network part, then they can communicate easily or directly. But if you are having two devices which contain two IP addresses which is having different network parts, that means a separate network parts, that means they will consider as a separate networks. So that is the meaning of logically separated networks. So if you are having a two, not two machines actually, you are having a one LAN. So you are having a one building or one LAN with another network. Then you are having another building or another LAN which is having a different network. Then those two network IPs, those two separated networks IPs machines, they will not able to communicate to each other because they are separated, logically separated. Now, if they are in same network, then for connecting them, we can use hub or switch. But if they are logically separated network, then they cannot connect directly by using switch or hub. And then we use these routers. So these routers are for basically, or the main task for the router is to connect two different logically separated networks. That means the whole network. We are not talking about a single IP. We are talking about the whole network. And in a network, we can have lots of IPs, and each IP, that means each node, that means one node will get one IP. So when I say lots of IPs, that means we are talking about lots of nodes. We will see in IP addressing when we do this how many networks we can have and how many IPs or how many hosts which can get the IPs. we have in one network. Now each network is identified by its network address. That is what I said, that network part address. And that means every IP address has two parts. One is a network part and second is a host part. So their network part identified the network, that is called network address, and a logical name assigned to it. Now logical name assigned to it, that means whether it is class A, class B, class C. These are the logical name for that IP addresses. Or we can say, if you have a machine, single machine, then you can consider them as a IP, or we can assign them a name. Now for that, to resolve the name from the IP, we need another service, that is DNS, that is the other thing. Now each network in an internetwork must be assigned a unique network address. That means if you are having a 20-50 machines in a same LAN network and you want them to communicate to each other, then you have to consider that you have to configure the same network, same unique network address to all those 50 or 100 machines so that they can communicate to each other. Now a router has a lot more capabilities than other network devices such as hub or switch. So hub or switch simply can connect same network devices. That means the devices which is in the same network address, in the same network, which is same network IPs. But the router can connect and a switch that are only able to perform basic network functions. For example, a hub is often used to transfer data between computers or network devices, but does not analyze or do anything with the data it is transferring. That is the job of hub. Hub does not know. Basically, hub does not know like what the IP addresses are there or which machine is sending the data to which machine. Hub does not know anything. It just do broadcast. That means it receives the packet, it is receives the data on one port and send it to all the other ports. It does not know like who this data is belonging to which device, or which device is on which port, because it does not read any packets. But by contrast, routers can analyze the data being sent over a network and change how it is packed and send it to another network or over a different network. So basically, not only the two networks, routers can connect multiple to different networks. It can be, you can consider it like a, we can say like it's a traffic. You are having a lots of different ways to go somewhere, and these are the traffic guide who can guide the cars to go to a proper path. So it is like, if you want to go somewhere, then you go to this router and you will ask, I want to go here, but how and where I can go. So router can give you the path. It will route you to that path. So that is why basically routers called router, because they give a route to you, that where you want to go. So not only it connect two different logically separated networks, it can connect you to a multiple different separated networks. That means you're having a LAN network in your area, your building or your office, and you want to connect it to multiple other networks. So you can do it by using this router, and it is also sitting on the gateway. So we can say this is also a gateway device. So the router operations. This is the router's operation. Routers are typically much more processing intensive than bridges. Now when it says bridges, that means we are talking about switch. Yesterday also I told you that bridges was the first device which came before the switches. After the bridges, then the switches came. So as a result, their processing speed generally measured in packets or block of data forwarded per second. Now this routers do lots of job than switches or bridges. It is more processing intensive, because if suppose you are having 200, or suppose you are having 500 machines in your local network, and you want to go from your local network to other network, That means you can go only from the gateway, and that gateway is managed by the router. That means the single router has to manage all the 500 machines data. They are continuously sending the data and continuously receiving the data, and all the data is going through the router. So the router has to be more process intensive. So it is speeds are measured in generally what in packets blocks of data forwarded per second. That means how much data or how much packet it can process and forward and receive in the per second, and are not usually as high. So routers are capable of much more sophisticated path selection, and it can select more sophisticated paths. As I said, it is not only connecting two different networks, it is connecting your network to multiple other networks, and it can be a sophisticated network path to choose. The decision to buy a bridge or a router hints on specific requirements in the specific network environment. That means if you are wanted to connect only the devices within your local area network, then you don't need router. The bridges and switches can do your job. But if you want to connect your devices, your local network devices to outside network devices, then you need what router. For example, you are configuring WAN network. You are having an office in one city, and you are having another offices are in other cities. Another cities like city 1, city 2, city 3, somewhere in different cities, different countries. And you want to connect your office of this city to other offices of the other country or other cities. Then what you need to have what a different WAN connection, lease lines. So you will connect your local area network to the router through the router to the lease line of the ISPs, service providers, and they will forward your data to the other office of yours, and there also you have what routers to configure to manage this. So these routers can manage those connection from local area network to wide area network, or even an internet also, so that it uses to choose the sophisticated path. We will see how these routers work and how we can decide the path and what is the configuration of the router. Just like this, if you see the image, that is the diagram. You can see this is your local network where you have connected different segments of switches, which is connecting to the different your main switches or bridges, and then those are connected through the router and going on to the WAN network through the ISP, and then they can go to other network of other cities. So this router, you can see it is handling all the network of these different segments, and it can be a big network. It can be a 500 machines to 1000 machines, and all of them has to be processed with router. Now this is the next topic. Those are the devices we have seen. Now we will see how we can configure those routers and switches. Hubs are not used. We will see how we can configure the access points also. But before configuring all of those, we have to make sure that we understand the logical things properly. Then we will configure the practical things. So the most important thing about the networking is this OSI reference model that you have to understand properly. So we are going to start this. Early days of the networking, we have separate devices of separate companies, different protocols they use. What is the problem there, like everyone using their own models, everyone using their own way to communicate, and the problem is they are not able to communicate to each other. Like for example, IBM, Apple, they are using their own ways of connecting. They are using their own communication styles, hardwares, and they are not able to communicate to each other. But the network is expanding. The network is it is expanding very fast. So the communication problem came. So ISO is a standard setting model, a standard setting organization. It is an organization for standardizations, international organization for standardization. So they have configured, they have made this model, and remember, it's only a model. It is not a, it is not a compulsory thing, not a compulsory. It is not used actually. It is not used everywhere. It is actually a model. So the whatever everyone used, it is based on this model. Not exactly like this, but it is all like this. So actually what model we use right now is TCP IP model. It is not OSI model, but they are same. There is a very little different in that, but actually they are same. So it is a reference model. So whenever you say OSI, it is a reference model. So the company or the devices, who wants to make hardware devices, or who wants to make a software devices, they take the reference from this OSI reference model. So if suppose I am a hardware vendor, I want to make some networking device, so I can decide like I will make the device for which layer. Now this OSI layer contains 7 different layers, and each layer do a different task. So we can make a hardware device based on a particular layer, that this device will work for only this layer, and this device will work for only this layer. And it is also helpful if you want to do the troubleshooting. So when you want to do the troubleshooting for your network problem, then you can easily detect the problem by making sure that which layer is giving you the problem, because every layer is doing a task for communication. That means if your data is coming from one machine and going to the other machine, that means it is going through all those 7 layers of OSI, OSI reference model. So it is going from the all the 7 layers of OSI reference model, and each layer is doing their job on that data. So if you are having any problem that data is not sending or not receiving, then we can assume that which layer is giving the problem, and we can reconfigure or we can reset the layer. And it is easy when you are having a separate device for a separate layer. So you don't have to change the whole model. You can just change or troubleshoot only the layer which is giving you the problem. So this OSI reference model, it's a network reference model, and is a conceptual framework for understanding the relationship between different entities within a network. Entities refer to all the software and hardware elements which are part of the networking, and the core objective of the reference model is to have interoperability among multiple vendors, so that the products, both software and hardware designed by one vendor, can communicate or work with the products manufactured by the other. And that is also the case, like one vendor, like then when we define the model, then when IBM making a new product or Apple making a product, they can all communicate to each other because they are following the same reference model. Now there are two important networking reference models, that is OSI, which is Open System Interconnection, and TCP IP model. It is also called Department of Defense model, Department of Defense model, which is which is actually uh, created by the, suppose you can say it is created or designed by the Department of Defense, US. So first, open system interconnection, OSI. The open system interconnection model is a conceptual model that characterizes and standardizes the internal functions of a communication system by partitioning it into abstraction layers. And the model is a product of the Open System Interconnection Project at the International Organization for Standardization, ISO. Now this OSI model, this model consists of 7 layers. So we have 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Now when we talk about these layers, when we talk about these layers, so we say these three layers are what? Upper layers. Then you have middle layers, then you have lower layers. Now as you see the names, if you see the name, the first layer is what? Application layer, and the last layer is what? Physical layer. But if you see the numbers, so the first layer is actually physical layer, and the last layer is actually application layer. Now why I am writing the layers like this? Why not I'm writing it from the first layer to 7 layer from the beginning? Like why I'm not writing it from physical layer, then data link layer, then network, transport, session, application, and presentation and application? Why I'm not writing like this? Why I'm writing like this? Because numbers are starting from the bottom, but I'm writing the layers or names of the layers from the bottom up. Now why I'm doing this? Now because as I said, when you send the data, like suppose this is my machine, and if I'm sending the data to from my machine to another machine, so it will go through all these layers. So when the data is going out of your system, remember it is not still get it out, now it is going out of your system. So first layer it will met is application layer when the data is going out of your system. Then it will meet presentation, session, transport, network, data link, and physical layer. And that is why I write the name like this, because your data is going out of your system. And finally, after the physical layer, your data will come out of your system and goes into network. It goes into network. Now, when the data receives, on the other hand, like you're connected to other machine, and now data is going to this machine, and now data is getting into that machine from here. Now, when data is getting into the system, then the first layer it will meet is this physical layer, then data link layer, then network, transport, session, presentation, and application layer. And that is why the number starts from the physical layer. So the numbering of the layers is given from the receiving end. Remember, the numbers are given from the receiving side. If suppose it is given from the sending side, then the first layer will be application layer and the last layer will be physical layer. But no, the numbering is given from the receiving side. So thus these numbers are from the receiving side. So what if someone says which is the third layer, then you will say network layer, not session layer. But when you write the layers, you will write it like this, because you are explaining that the layers, these layers are from the sending side, but when the data received on the other end, it will be go through these numbers. So the numbering of the layers are from the receiving side, but when we write the name of the layers, we write from the sending side. So when your data go from your machine, then it will meet the first layer, and that layer is what? Application layer. Now every layer will do their job on that data. So this application layer it do what? It integrates network functionality into the host operating system. That means whatever operating system you are using, you're using Windows, you're using Linux, you're using Mac operating system, it will integrate the network, integrate like network functionality. It will provide the network to your application, your operating system, and enable network services. So it provides the networking services to your applications. Applications, that means your host operating system, that is also application, and also the other applications which is network aware applications. Now which applications are network aware? Those applications which uses the network. Remember, those applications which uses the network. Your operating system uses the network, your network browser, internet browser uses the network. If you use any web mail client like Outlook, it also uses the network. But nowadays if you see all the applications, most of the applications uses the network. Even the PDF reader, it is also using the internet. Why it is using the internet? For getting the updates. Or even you can connect this to share your PDF file directly with the internet. You are having an option here to share on cloud, and also you can directly print from here. So it is also using the network. So most applications nowadays in our system uses the network. They all are network aware applications. So providing the network features, network services to those applications, that is the job of application layer. And the application layer does not include specific application that provide services, but rather provides the capability for services to operate on the network. So these services include like file services, that means transferring, storing and updating shared data. Then print services, enabling network printers to shared by multiple users. Then message services, like transferring data in many formats like text, audio, video from one application to another or from one user to another. Data is going from browser, Outlook, or going from any other application. The information is on application layer, like which application is using the data, which application is using the network, and providing the network feature to that application is the responsibility of application layer. Now after the application layer, now these are the services for the application layer, like message services, and then application services also, sharing application processing throughout the network and enabling specialized network servers to perform processing tasks. Network servers, like we are having Microsoft Windows server, we have Linux servers, they do have another, the multiple network services like DSCP, DNS, lots of things are there. Then database services also, storing, retrieving and coordinating database information throughout the network. So this is the task for the application layer. Now after the application layer, your data is generated. That means the application layer's basic job is to take the data from application and forward it onto network. Now if the data is coming from network browser, it is coming from Internet Explorer, or it is coming from Outlook, it is coming from any other application. So taking the data from the application and forwarding it into the network. Now forwarding it into network, that means it will forward the data to another layer, the next layer, and the next layer is presentation layer. Now presentation layer do what? This presentation layer formats or present data into a compatible form for recipient by the application layer or the destination system. Specifically, the presentation layer ensure, these are the things which presentation layer ensure. Now first, what it do actually, it formats the data, like present the data into compatible format. Compatible format, that means some of the data are in different format or advanced format which is not able to understand by the all other different machines. So it do what? It present the data in compatible form so that everyone can understand. So first, presentation layer makes sure that formatting and translation of data between systems. Then negotiation of data transfer, syntax between system, through converting character sets to the correct format. So it is doing what? It is formatting the data to be understood by the all other recipients. Compatibility with the host. That means the other host can be understand the data. Encapsulation of data into message envelopes by encryption and compression. Now it will do what? It will do encrypt the data for security and integrity. That means if you are sending a data and you want some application now, or not all the application do this, but some application demands the encryption, demands the security encryption. So it is done by this presentation layer. It is encapsulation the data envelopes by encrypting it. And also some of the application demands compressions. Like suppose you using WhatsApp. When you send any video file or image file on WhatsApp, it do what? It compresses it. Compress means it compress it to make the small size so that it can easily go upload on server, and in other side it can easily download it. So application is demanding the compression. So the compression job is done by presentation layer. Encryption, compression. Restoration of data by decryption and decompression. Now data decryption and compression is also done by presentation layer. Now where it will do this, that means what? When the data is going out of the system and when it reaches here in the presentation layer, and if the application demands encryption, so it will do what? It will encrypt data here. If it demands compression, then it will compress the data here. Now when the data goes out and received on the other end, receiving side, and when it reaches to the presentation layer, so because on the presentation layer it has encrypted the data, so it will decrypt the data on other side. And if it is compressed on the sending side, then it will be decompressed on the receiving side. So it do what? It compress and decompress. That means it re-encapsulate for the data to make an envelope of encryption and compression. Then other end it will do restoration of data by decryption and compression. Now the presentation layer format data for the application layer, therefore it's also sets standards for multimedia and other file format. So it also set the formats for the application actually. Application, that means for the other side, like when the data goes out from here, so it knows that which application is sending the data. Is it a text file? Is it a video file? So when it reaches here in the other side, then this side also machine should know that the data is for which application. So for that it sets the format for the data, so that when it reaches the destination, it will understand, the destination machine understand that this data belongs to which application, and according to that it will send that data to the application layer. And for that it do what? It formats the data with different formats, multimedia formats, such as you can say this JPG, bitmap, TIFF, PICT, MPEG, WMA, AVI for video, ASCII text files, EBCD, EC, IC, MIDI wave sounds files, MP3, lots of formats are there. So these are also decided on the sending side, and then in the receiving side the application understand that which the data belongs to which application. Like if it is a JPG file, then it is going to be open in the image viewer. If it is a MPG file, then it is going to be open in the video player. Then after doing this, like setting the format, doing encryption or compression, and then the data come to session layer. Now the session layer is primary function is the primary function for the session layer is managing the session in which data is transferred. That means the data, the layer, this layer's job is to just manage the sessions. Now what do you mean by session is that when you connect any machine, like if you connect from this machine to this server, For example, this is your machine and you are logging into Gmail. Now when you log into that server, when you log into Gmail, you connect to the Gmail server, then what happened? The session is established. That means from your machine to the server, the session is established and it is called the session. And you can have multiple sessions established. You know, in one tab you connect the Gmail, in other tab you open connect YouTube, in another tab you connect Facebook, in another tab you connect another server, another site. So you're doing what? You're connecting multiple, you're creating multiple sessions from your single machine, from your single LAN card, from your single cable. You're connecting multiple sessions. Some sessions are going out, some sessions are coming in. So managing all those sessions is the job of session layer first. So this is the primary function for the managing, for the session layer, to manage all the running sessions of your system. Then functions at this layer may include, and that is what, establishing and maintenance of communication session between the network host, ensuring that data is transported. So when you connect your net to the other server, the connection, the session will be established and it is going to be maintained by the session layer so that your data will go. Then management of multiple sessions, like each client connection is called a session. Remember, a server can concurrently maintain thousands of sessions. Specifically for server, we are talking about client, but what about the server? In this server, thousands of millions of different users are connecting. Like suppose this is Facebook server, so you know how busy it is. So it can be connected by thousands of millions of different users, and each user is having their own session. So it has to be managed by the session layer. Then assignment of the session ID number to each session, which is then used by the transport layer to properly route the message. So it also uses the session ID for every session, and that is also used by the transport layer. The next layer is what? The transport layer, which is very important layer, which do lots of tasks. So it also do properly route the message so that it gets the session ID by the session layer. Then dialog control is specifying how the network devices coordinate with each other, that is simplex, half duplex and full duplex. As we have seen that previously, simplex connection where you have only one way communication broadcasting, half duplex, that is only one way connection, that means one way in or one way out, and full duplex, that means simultaneously we can have two-way communication, full duplex. So that is the job of also session layer. Then finally, termination of communication session between network host upon completion of the data transfer. That means when you disconnect the server, when you finish your task, you log out, you disconnect, that means your session is terminated. And that is also the task of session layer to do that. That means it establishes the session when you connect. Then when as long as you're connected, it maintains the session. And then finally when you disconnect, it do what? It terminate the sessions. Then it comes the transport layer. Now this transport layer is very important. And till here your data is ready. Now you see it is called upper layers. These three layers is called upper layers. Now why these called upper layers? Because till this third layer, like session layer, your data is ready. That means your data is ready. This is your data and it is called PDU. It is called packet data unit. It is completed here, and now this data is going to be sent on the network. So till the third layer, session layer, not third layer actually, it is a fifth layer, but till the session layer your data is completed. That means it is decided that your data, which data is going to be sent on network. And from here, this transport layer's job started, and that is what it's a middle layer. If you talk about the networking side, that means for CCNA part, like for us, these three layers, these application, presentation and session layers, these are not that important for us. Now why I'm saying that not that important for us, because the these three layers job, it is done by the application and operating system. That means network administrator is not responsible for these three layers. If anything goes wrong with these three layers, you can't do anything. You can change, you just have to, you just change the application, because it is itself in an application. So you can just change the application or operating system, it will be solved. Now the real task starts from this transport layer. So after PDU is created, then the transport layer comes, and that transport layer, the data will come to the transport layer. Now transport layer provides a transition between the upper and lower layers of the OSI model, and making the upper and lower layers transparent from each other. Now upper layers format and process data without any concern for delivery. That means till now they don't concern about delivery, and that is why that is not important for networking side. Now lower layers prepare the data for delivery for fragmenting and attaching transport required information. So all the transport required information and all the transport related things will be done by the lower layers. And function of the transport layer is, first, service point addressing. Service point addressing means transport layer header includes service point address, which is port address. This layer gets the message to the correct process on the computer, unlike network layer, and which get each packet to the correct computer. So first, this layer's job is to add the port address. Now what is the port address? First, in a network, anything is happening on the network. If the data is coming and going from one machine, everything is doing or done on a protocol. Protocol is what? It's a network protocol. So we are having lots of network protocol which do everything on the network. Now these network protocols are having the name like DNS, DHCP, FTP, HTTP, and we understand them by name. But for machine don't understand the name, so they understand them by their port number. So every protocol in a network, they are having a unique port number. We can say service point addresses, and you can assume them as a lane in a super highway. So when the data goes on the network, so these port addresses decides that which lane your data is going to be on highway. Like let's assume your cable is the highway, which contains multiple different lanes of cars or different vehicles, and that lanes defined by the port number. So your system knows that which lane is for which port number. As you can say, lanes are what? A session. So if this session is for this port number, that means this lane is for this port or this port, and port means what? Application. So it is managed by the transport layer, that your data which is coming from all these upper layers, and it is already created, the PDU is created. So the data is coming from which application, and now which protocol is going to be used to send the data. So based on the protocol, it assigns the port number. Suppose if it is going for HTTP, so the port number will be 80. If the data is for FTP, then the port number will be 21. So like this, you're having lots of different well-known protocols and they are well-known port numbers. But the port number we have total 65,535 port numbers we have. Now why I'm saying 65,535, because the address, this port address value, the size of this port address value is 16-bit. It's a 16-bit address size. So in a 16-bit, you can have a number of 65,536, but because 0 you can't use for port number, so it is actually 65. 0 port number, that means nothing. So that is why you can't use 0 for port number. So port number starts from 1 and it can go up to 65,535, and that is why, because it contains the 16-bit address. Now all those port numbers we are not using because you don't have the protocols. So well-known port numbers which is we used normally for protocols are from 1 to 1023. These are well known, these are reserved for well-known protocols, and you can based on the application, it will be assigned by the transport layer. The unique port number is assigned by the the transport layer, and you also know, you should also remember all the protocols and protocols port number. That is also the network administrator's task, is to remember all those protocols and their port numbers. Then the next task for the transport layer is to segmentation and resembling the data. That means a message is divided into segments and each segment contains sequence number, which enable this layer in resembling the message. Message is resembled correctly upon arrival at the destination and replaces packets which were lost in transmission. So first it do what? Segmentation of the packet, segmentation of the data. That means your PDU is created here till the session layer, and suppose this packet, this PDU is of 100 MB. Now suppose this is 100 MB. Now 100 MB we can't send at the same time on network. So what this transport layer do? It will divide the packet into multiple small segments. For example, it divided into 1 MB segment. So it will divide this packet into 100 different segments of 1 MB. And those different segments is also we will call them as a PDU, because they are same as this PDU. This is the same data which we have. Now every PDU, those 100 PDUs, 100 different 1 MB PDUs will go through with this all other layers. So after transport layer, all these 3 layers will do the job on each of those packets, each of those 1 MB PDUs. Now when these packets are segmented here in the sending side, then when they reaches on the destination, then they may not be reach in sequence. They may not reach in sequence because on the way some packets go fast or some packet go slow, or maybe if you're sending it in different ways, different paths, then it can go like one packet goes on different path, second packet goes on different path. So sometime what they will not, it is not necessary, or it will never reach on the destination in sequence. Now if they reaches on the destination and it reaches on the transport layer, now transport layer job is to do what? To do the reassembling. That means after segmentation, in this receiving side, it has to reassemble the all different packets of 1 and 1 MB to create this 1000 MB PDU again for session layer. Now how it can do now? So for that, it do what? When it segments the packet, it assigns sequence number to each and every packet. That means the first segment of the packet will get sequence number 1, second packet will get sequence number 2, then sequence number 3, sequence number 4 till the 100 sequence number. Now every packet knows that how many packets it has. Like if it is the segment 1, like this one has sequence 1, so it will be like sequence number 1 out of 100. That means it has an information that this is the part of 100 different packets and this one is the first one of them. This one is the second of the 100 packets. This is the third one of the 100. So when they reaches on the destination, and they may not reach at the destination in sequence, like suppose first reaches number 2. So when it reaches here, then the receiving side transport layer knows that this is number 2 out of 100. That means now this is number 2, but rest of the packets are coming. So I have to wait till all the packets are come. So till all the packet will come, till then I have to wait there. So they will come like 2, then 10, then 100, then 99, then 80. So like all the packets will come on the destination, and when they all reaches here on the destination, then what? The transport layer do what? It will reassemble the packet to create this 100 MB PDU. Now sometime what happen? Some packet may not reach. They may lost on the way. So what? Transport layer's job is to make sure that all the packet comes, then it will make the PDU again. But if they don't reaches there, then you may have what? Corrupt packet, or you may have lost your transmission. But there is a twist here. For that, it will use what? Connection control. So maybe you can lose the data. Now for that, you have this connection control, and it includes two type of connection control. And that is also the task of transport layer, to make sure that the data reaches on the destination properly. So it uses two connection control type. One is what? Connection less transport layer, using what? UDP. It is user datagram protocol, and this is also a protocol. And it do what? Each segment is considered as an independent packet and delivered to the transport layer at the destination machine. Now in this way, what happens if the data reaches with this way? That means if the data is going, this PDU, these segments are going and using the UDP protocol for connection control. For connection control, if they are using UDP protocol, then what? This receiving side does not wait for every packet. That means it will not wait for the packet, that if suppose the packet lost, if suppose two packets not come, if two packets not come here, then what it will do? It will consider the data as corrupt and it will drop. It will give you error that the data is not reached, the data is corrupt. So in receiving side, you will see the error, data don't reach, corrupted. But and also it will not reply here. That means on the sending side, you will not know. The sending side also don't know that the data reaches the destination or not. So it is not having a guarantee that your data is compulsorily reaches the destination, because if the data goes there, the receiving side does not care about it, whether it is coming. If it is all come, then okay, and if they don't come, then it's also okay. If they come correctly, then it will create the PDU and passes to the other layers. If they don't come, no problem, no error. It will not give error to the receiving side, it will not give error to the sending side. Nobody knows it, because it is what connection less protocol. Connection less protocol, that means it does not care about the connection. It does not care about the receiving or sending side. It will not give any error to receiving or sending side that the data is reaching the destination or not. That means you don't have your data is not guaranteed to be reached to the destination. So it is no guarantee that your data will reach to the destination. There is no guarantee, no warranty. If your connection is right, then the machine will reach the data. If their connection is not right, you will not get the data. That means it is just like what this machine throws the data to other machine, whether the machine is there to catch it or not. It does not care. That means it just throw the data to other side, whether the side is there, this machine is running or not running, it is ready to catch the data or not ready to catch data, no problem, it is just throwing the data. So there is no guarantee that this data will reach to destination by using UDP. But on the other hand, the another thing is what? Connection oriented transport layer using TCP. Now this TCP was connection oriented. This TCP is connection oriented. TCP means transport layer control, transport transmission control protocol. This is called transmission control protocol. Now this will do what? Before delivering the packet. Now remember, before delivering the packet, connection is made with the transport layer at the destination machine. That means if the data is going with this UDP, TCP protocol, then first what it will do, this transport layer will make connection to another transport layer of the receiving end. That means it will ask the another machine, destination machine transport layer, that are you ready to get the data or not. If this machine says yes, I am ready, only then this machine will send the data. Otherwise it will not send the data. That means it will send the data only if the destination machine is agrees to take the data. Remember, agrees to take the data. That means suppose if it is sending the data of FTP protocol, the data is FTP data. Now the machine, the destination machine is running, and this machine says, this transport layer says, this machine's transport layer, that are you ready to accept the data for FTP. Now this machine will check its own machine that whether the FTP service is running here or not. Now if the FTP service is not there, then this machine will say no, I am not ready to take the data because this service I don't have. But if this machine contains the service and is running the service and is also accepting the data from the other machine, because maybe the service is running but maybe it is not accepting data from other machines, so it is also say no. But if the machine is running the service, then it will say yes, I am ready to take the data. Then only this machine will send the data from here to here. That means before sending the data, it will establish the connection. That is why it is called connection oriented protocol, TCP. Now after connection, establishing the connection, then it will start sending packets one by one. Maybe this is what, having 100 different packets. Now it is start sending one by one each packet. Now when they reaches the destination, and make suppose these two packets are not reached, they dropped in the way. Now the TCP makes sure that it will get the response from the other side, that whether they are getting all the packets or not. Now if they don't get one or two or three packets, then this machine will send the reply to this machine saying I am not getting these two packets. Now what? This transport layer will send again those two packets. That means it will again send the packet to this machine and send, and then ask, do you get it? Then it will say okay, yes, I got it. Or if it said no, I don't get it, then again it will send the packet to that machine. So whenever this transport layer using TCP go send the data, it will make sure the data will go and reach the destination. So it is guaranteed that the data will reach the destination. and in other hand UDP, no guarantee. After that, transport layers another job is to make sure the flow control. Now before that, let's see the difference between TCP and UDP. These two these two are protocols, so they are different, and this is the difference between these two protocols. Now what is the difference here? So first, TCP, as I said, it is what connection oriented protocol. So this is what connection oriented protocol, and connection oriented means that the communication device should establish the connection before transmitting the data and should close the connection after transmitting the data. So it have to establish the connection before sending the data. But on the other hand, UDP, it is user datagram protocol. It do what? It is a datagram oriented protocol, and this is because there are no overhead for opening a connection, maintaining a connection, and terminating a connection. UDP is sufficient for a broadcast and multicast type of network transmission. So basically it is used, this protocol is used for basically broadcast and multicast type of communication, where we send data from one to all, no communication, no two-way communication, just send the data. And it will do what? It will not establish any connection. It will not take the overhead of establishing, maintaining, or terminating the connection. Then in this, TCP is reliable. It is reliable because it is guarantees the delivery of data to the destination router. That means it guarantees the data, like when it sends the packets, it take the acknowledgement, like the other machine is getting the data or not. And if the other machine says that it is not getting the data, then it will send again the same data. Now this makes UDP what? The UDP do what? It deliver the data to the destination cannot be guaranteed in UDP, because it is not checking that other machine is ready to ready to take the data, or it is available or not available. And also it will not get any acknowledgement that the data is reach the destination or not. Now TCP provides extensive error checking mechanism. It is because it provides flow control and acknowledgement of data. So when it sends the data, it gets the acknowledgement from other side that the data is reached there or not. And also it uses the flow control. That is what here, flow control, error control. These are also available only TCP. If you are using UDP, no, it is not using that thing. UDP has only the basic error checking mechanism using checksum. Then sequence of data is a feature of transmission control protocol. Sequencing of the data is also TCP funda, like when you make a sequence number. This means that packets arrive in order at the receiver. But in the UDP, there is no sequencing of data in UDP. If ordering is required, it has to be managed by the application layer. That means when it segments the data, if it is segment the data, like UDP mostly don't do the segmenting of data. But if the data is very big and need to be segmented, then the sequence number is not there in UDP. It is only there in TCP. If you are using TCP, if the protocol is using TCP, then the sequence number will be there for reordering the data in the receiving side. But in the UDP, mostly it does not use the sequencing, does not reuse the segmentation. But if in case it do, then the management of the sequencing is managed by application layer, not the transport layer, not the UDP protocol. Then TCP is comparatively slower than UDP. That is the point here. The main point is this: why we use TCP or UDP. That is what you may ask, like you are thinking, like if the UDP is not secure, it is not guaranteed, it is not doing anything, so why we are using this UDP? Because of this. Now TCP makes sure that your data will reach the destination, but it works slower than UDP. it will take lots of time to do all these things. So it will take time, but UDP is faster and simpler for more efficient than TCP. That means for speed, UDP is very best. So basically what some of the protocol, in some of the protocol, data is important. The speed is not important. For example, if you're sending mail to someone, for sending the mail, we use SMTP protocol. Now that SMTP protocol uses TCP for transmission the data. Now why? Because mail is important. Mail, that means you're sending important data. If it is going slow, no problem, but the data must be reach the destination. So this protocol, SMTP protocol, uses TCP. Now other hand, suppose we are using DHCP protocol. DHCP protocol's job is to assign IP addresses to machine, automatic IP addresses. Now suppose when we start the machine and we want to have a IP from DHCP server. Now we need quickly, we don't want to wait it. So if it is not reaching, if it is getting fail in the way, no problem, but I want is to have quickly. That means the data is not important. The data means the IP which is coming from DHCP server to my machine, the request and replies, that is not important. The data of those TCP communication is not important, but the speed is most important thing. So what we use UDP for that. Or suppose some kind of streaming videos, like you see the streaming videos, online videos, those protocol also use UDP because speed is important, data is not important. If you miss some data of some pixel, so you just lose the pixel on your screen, and you will take it will go, come and go, you don't care, but you can't wait for it. Then retransmission of lost packet is possible in TCP but not in UDP, because if some packet is lost, so it is getting the acknowledgement, so it can retransmit those packet, but because UDP is not getting any acknowledgement, so retransmission of those lost packages are not done. So TCP doesn't support broadcasting, but UDP support broadcasting. So basically UDP also uses for broadcasting. As I said, online streaming videos, they are broadcasting. So also uses what? UDP. But in TCP you can't do broadcasting. So this is the difference between TCP and UDP. And this TCP do what? Connection establishment. That means before sending the data to other machine, it establishes the connection. And for that, it uses this three-way handshake. It is called three-way handshake. And in other hand, UDP do what? It does not do any connection establishment. So how it will communicate? It will just communicate directly, plain. That means in the UDP side, it just send the request, response, request, response, request, response, response. But for TCP, first it will establish the connection, and for establishing the connection, it uses the three-way handshake, TCP three-way handshake. Now TCP handshake means first, when these machines try to connect the other machine, sender try to send the data to receiver. Let's say I am talking about FTP. So first this sender will send what? A sync, a packet, a small packet with a sync flag. These are the flags of TCP protocol. These are called flags of TCP protocol. So it sends one packet, a simple flag packet, TCP packet with the sync flag set. Sync flag set, like you can say, it is a you're having a packet with the different flags, and with that it just check this sync, like it is a sync packet. Sync means synchronization, and you can assume it like this sender is saying the receiving machine that hello, I want to do the communication for FTP, and remember it uses the protocol number also. So it knows that which protocol communication it want to do. So it sent the sync packet, sync flag set TCP packet for FTP to the receiving side. Now the receiver knows that the FTP service is running on that machine or not. If it is not running here, then it will reject the request. Otherwise, it will do what? If the machine is having the service, then it will send what? Sync and ACK. It set a sync ACK flag on the packet and send it to the sender. Now that means what? It is saying acknowledgement. Acknowledgement and sync. That means what? It is the receiving side saying like, I am okay, I am ready, are you ready? So it says what? I am ready to accept the packet, are you ready to send? Then this sender will say okay, and it said it will send acknowledge ACK flag set, a packet which is ACK flag set to the receiver. And after this three-way communication handshake, the connection will establish. So what sender says, hello, I want to do FTP communication to you. Then receiver said, okay, I am ready, are you ready? Then sender says, yes, I am also ready, and the connection is established. Now the connection is established. After that, the data will be sent from sender to receiver. Now when the sender sends the data, it manages the flow control. It manages the flow control also. And flow control, error checking, that means it makes sure that every packet reaches the destination by using what? Acknowledgements. And after the communication is completed, then what? The receiver may be waiting for the next more packets. So the sender will send the reset flag set packet to this receiver. Sender will send one packet with the reset flag. Now reset flag means it is saying like, okay, I'm done. No, not reset actually. Sorry, it will send fin flag set. It will send the packet with the fin flag. Now fin flag means finish. Finish, it is saying what? I have done with the sending data. Finish. Now you can close the connection. So this receiving side will confirm it by sending the reset flag. Reset flag means the connection, I'm resetting the connection, and if you want to do the connection again, then you have to start from the beginning, like from the beginning, like from sending the sync and then sync ACK, then ACK. So after completing the data, the sender will send the fin flag and the receiver will send reset flag. And suppose if the application is not running here, the service is not running here, so when the sender sends first sync, the receiver will directly send reset. It says no, I don't have this service. And this UDP do what? It will simply send request and get response. Done. Now the flow control, it will manage when it is established the connection and when it is sending the data. In this layer, flow control is performed end to end. That means it will manage the flow control of the data by giving and receiving the acknowledgements. Error control, also a job of TCP. So it do what? Performed end to end in this layer to ensure that the complete message arrives at the receiving transport layer without any error, and error correction is done through retransmission. Retransmission means what? If the packet is errored, like if the packet not reaches the destination, maybe it is error or some corrupt, so the receiving side will send the acknowledgement that I'm not getting the packet, it is corrupt or not reached. So the sending side will do what? To correct the error, it will do what? It will retransmit the same packet. So it will retransmit the same packet to correct the problem. So it will actually not error correction, it will do what? Retransmission the error packet. And this is what a job of transport layer. So it do lots of job. Now after that, the data comes to the network layer. Now remember, data comes to the network layer means what? The data is this PDU. This is our main data. Now it is divided into multiple different segments. And if it is using TCP, it is divided into segments and used a segment sequence ID. Now these packets are going one by one to network layer. Not all of them, one by one those packets are going to network layer. And then we can say this is what a PDU, one of them, one of the PDU of those 100 PDUs. Now when it reaches here network layer, this transport layer do what? In that PDU it attaches the information of itself. It is called header. It added one header into that basic PDU of transport layer. Now in this header it will add all the information of transport layer. Now all the information of the transport layer, that means the port numbers, based on the protocol, that is sending port number, receiving port number. Now sending port number is the source port number is the sender's port number, destination port number is the receiver's port number. Now destination port number will be defined by the protocol. Like if it is HTTP, then the destination port number will be 80. If it is FTP, the destination port number will be 21, and so on. So destination port number will be defined by the protocol, but the source port number, it uses randomly any number. Now any number, that means I said the numbers can be from 1 to 165,535. So it can use any of those numbers. Now any of those numbers, that means after well known. Now well known, I said 1 to 1023. So after 1023 it can use any number, and it attach those numbers. Then if it is a packet of sequence, different segments, then it is sequence IDs and other information. So all those information will be added here in this header of transport layer, and then total the PDU and the header of transport layer will go to network layer. Now the network layer do its job. And what is the network layer's job? So the network layer describe how data is routed across network and on the destination. And network layer function include maintaining addresses of neighboring routers, maintaining a list of known networks. So determining the next network point to which data should be sent. That means it determines the next address of neighbor address, like where you want to send the data. Now it uses network address, that means your IP addresses. So IP addresses are defined here on the network layer. Now which network address protocol you are using? Maybe you are using, there are other protocols are also, like IP is the protocol, internet protocol. Same as IP, you have IPX, which is old. Now we don't use IPX. And also we can have Apple Talk. Apple Talk is for Apple. Apple actually use their own routing protocol, that is we say Apple Talk, but basically we use IP. So with that IP you get the addresses, IP addresses, network addresses. So it is determined here in the network layer, which is determine the next network point to which data should be sent, like where the data should go. If your machine is connected directly, so your data will be, the address will be of the next machine, like your destination machine. Or if your data is going through the different network, so the next address will be the router's address, because the router can only connect to different networks. Remember, switches are invisible. These two machines, those machines don't know, sender or receiver don't know that there is a switch in between those two machines, or even a hub. But router, they have to know the router, because if they want to go from one network to other network, then they have to go through with the router. So if they connected directly or through switch or hub, the destination address will be the next address will be the destination machine. Or if they are connected through, you want to send the data to different network, then the next next network point will be router. So routers use a routing protocol to take into account various factors such as the number of hops in the path, link speed and link reliability to select the optimal path for data. Now if your data is going through the router, then router will decide. Now this is the task of router, which we will see also, that to define the path, like which path it should go, and how many hops, like how many routers it will go through, what is the link speed, and the link is reliable or not. So based on these different factors, router will choose a proper path for your network, for your data, and it will add add the address into this data on this network layer. So this network layer's job is to manage this thing. Now packet forwarded from the transport layer to the network layer become datagram and network specific. That means routing information is added, and the network layer protocol then ensure that the data arrives at the intended destination. That means when it goes on to this, so in network layer it will add one more header here, which will add the and network addresses information, like source address where the data is coming, and then the destination address where it is going. So destination address, that means the address of the destination machine, or if the destination address in the another segment or another network, then you will add the address of the router also. So it will go directly to the machine, or it can go through the router also. If they go through the router, then router will decide like how to reach this network IP. So it will decide the path based on those different factors: speed, hops, reliability. If it is going directly, then no deciding of path or anything, it will directly go to the machine. Maybe they are connected to directly cable, like we can connect those two machines directly from one cable, one cross cable. Or if you are having multiple machines, then you can't connect every machine directly, so you will connect them through the switch, but switch is invisible for them. They will feel like they are connected directly. So after transport layer added one header, the network layer will also add one more header into the data, and that will have the address information, network address informations like source address, destination address, router address, whatever. And then it will forward the data to data link layer. Now in the data link layer, this data link layer's job is divided into two sub layers. So basically it is divided into two sub layers. That is what media access control and logical link control layers. Like this, like data link layer is actually divided into two parts: logical link control and MAC address, like media access control. Media access control layer defines specification for controlling access to the media. That means how the media is going from one server, one machine to other machine. The MAC sub layer is responsible for what? Adding the frame start and stop information to the packet, like where the packet is starting and where it is going to stop, and adding the cyclic redundancy check for error checking. So it added one more thing here, CRC, cyclic redundancy checker, for error checking, then converting frame into bits to be sent across the network, then identifies the network devices and network topologies in preparation for media transmission, then define address such as MAC addresses for each physical device on the network, and controlling the access to the transmission media. That means this MAC, this media access control layer's job is to add what? It will add also one more header here. So when it reaches here in this, where you have PDU, so you are having a PDU, then one header for the transport layer, one header you are having for network layer. Now it adds one more header where it added this media access control information. It added these information like source and destination MAC addresses. Remember I said in local network only MAC addresses, the communication will be done on MAC addresses. So it added source MAC address of the source machine, then the destination MAC address of the destination machine, that means the machine which is going to receive the data. Also it added one more thing, that is what CRC. Now cyclic redundancy checker is for error. That means when the data reaches the destination, it is going through the cable, so maybe it is going to corrupt or something. So on the receiving side, when it reaches the data link layer on the receiving side, it opens the layer here, it opens this header and it checks the CRC first. It checks the CRC that it is okay or not. This CRC or FCS also we can say, these are for checking, it is for checking the error, but remember it cannot correct the error because the packet is already corrupted in the way, so it cannot recover the packet. But if it is error, then it will just remove the packet, and that is why in this transport layer the packet will not reach, and it says packet is not reached, so it will send the acknowledgement to this layer that it is not reaching, and it will send again the packet. So if the packet comes error, so this data link layer remove the packet, it drops the packet, it removes the packet. Now how it is, it added CRC here, and the CRC will be checked on the destination. We can assume simply it is very complex mega algorithm, but I will said like I will give you explanation simply. What it do actually, it also converts the data into binary. Remember, all the digital communications done on bits means binary means ones and zeros, and that is also done by data link layer, so that your data can be transported onto the digital media wire or digital devices. So when it converts into binary, that means bits, that means it converts into binaries. Binaries means zeros and ones. So let's assume your data consists of 11000001. So I can have like CRC can have an information, maybe I will say like simply CRC saying that you're having a data where you have total 20 ones. Now I'm not giving the sequence, and you are having zeros, 15 zeros. Now this is the combination of data. Suppose you are having a data in binary like 1100011100. Now total ones you have 20 and total zeros you have 15, and this is your CRC. Now when it reaches the destination, it opens the header here on the data link layer and it checks the data. So it checks the data here, all the binary of the data, and then it checks the CRC, and then it compares, is it 21 and 15 zeros. Now if the data is corrupt, so this combination, maybe this combination will not equal, maybe this ones are not 20, it reaches only 19 ones, it does not reach 20 ones. Then what it will say, that CRC is saying ones should be 20, but I am seeing only 19. That means data is corrupt and it is not right, and it will drop. Now I am giving you example only. It is not like that. It is a very complex algorithm. But this is how it checks the error. So after checking the error, it actually add the information about the error CRC, which is going to be checked on the destination side, receiving side, and after that it will convert it into bits so that it can be sent on the digital media. Then this logical link control LLCs provides an interface between MAC layer and upper layer protocols. This LLC protocol are defined by IEEE 802.2 committee. Now this is what IEEE is, the standard organization which sets the standard for hardware standards for this network or networking. So this is the task for this LLC is maintaining orderly delivery of frame through sequencing. So it is the job of this LLC to maintain the orderly delivery of frames. So whatever the frames it is going with this protocol, now remember it is going to be sent to the physical layer, and then controlling the flow or rate of transmission using the following: acknowledgement, buffering and windowing. So it is also manage this acknowledgements, bufferings and windowing. Then ensuring error-free reception of messages by retransmitting. So if it is error, then it will do retransmission also. Then converting data into an acceptable form for the upper layers, removing framing information from the packets and forwarding the message to the network layer, providing a way for upper layers of OSI module to use any MAC layer protocol, and define service access point SAPs by tracking and maintaining different protocols. Now this one is, these all tasks it do on routers. When you are sending normal one machine to other machine directly, then mostly these LLCs are not doing the job. These are actually defined on router to router communication. So after that, information like headers, and headers had it added the header here which is having source and destination MAC address, and for CRC it added one more thing, trailer. It is called trailer, additional information. Headers is an information, and trailer is the additional information where it adds the CRC. Now finally, data link layer do what? It encapsulates the data. That means it finalizes the data that now nothing will be added into this, and then it will do what? It will forward the data to physical layer, and the physical layer, as a name suggests, it do the physical job. It physical layers of the OSI model sets standards for sending and receiving electrical signals between devices. Like it is converted into bits, so it describes how digital data, that bits are converted to electric pulses, radio waves for wireless network, or pulses of light for fiber optic networks. And devices that operate at the physical layer send and receive a stream of bits. That means this physical layer's job is to transmit the data. Simple. So whatever the physical media we have wire media, we have wireless media, uh, we have fiber optic cables. So depending on that, it will convert the data into electric form and radio wave, microwave form or light form, converted into pulses of those digital signals, and then it will start sending the stream. So all the conversion and sending tasks will be done by the physical layer. What is the job of this service of this layer? Is modulate the processing of converting a signal from one to another, so that it can be physically transmitted over a communication channel, bit by bit delivery. Carrier sensing and collision detection, whereby the physical layer detects carrier availability and avoids the conjunction problems caused by undeliverable packets, and that is what it done in bus topology and also in hub and switches. Then signal equalization to ensure reliable communication connection and the facilitate multiplexing. Then forward error correction channel coding, such as error correction code, transmission mode control. So basically it is doing what? It is just making sure that your data will be converted into streams of bits and signals and to be sent properly on your physical medium. And these are the main task of these all 7 layers. Now there are some other things like in data encapsulation, de-encapsulations, and protocol data unit, PDU. What is it? So as I said, data encapsulation, what? The sending and receiving of data from source device to the destination device is possible with the help of networking protocols by using data encapsulation. And the data is encapsulated with the protocol information at each layer of a OSI reference model, and each layer communicate with its neighbor layer on the destination, and each layer uses protocol data unit PDUs to communicate and exchange the information. So it do what encapsulation means we are having a data encapsulation protocols which encapsulate data. Encapsulation means making a packet like capsules of the PDUs. De-encapsulation will be done on the destination side, and the receiving devices will synchronize on the digital signal and extract the ones and zeros from the digital signal, and at this point the devices build the frames, run a cyclic redundancy check, and then check their output against the output in the frame checking sequence and field of the data frame. If the information matches, then the packet is pulled from the frame and then the frame is described it. This process is known as de-encapsulation. The packet then transferred to the network layer where the IP addresses is checked. If the IP addresses matches, then the segment is pulled from the packet and then the packet is created. The data is processed at the transport layer that reveals the data stream and acknowledged to the transmission section that it receives each pieces of segment. It happily transfer the data stream to the upper layer application. That means like this. So data stream here, PDU till created here. Then from here it divided into data. You see multiple different data segments on transport layer. Then it added the header of network layer in the network layer. Then on the data link layer it added the header. It is the header of network layer. Then it add the header of the data link layer, and also trailer where you have a CRC and all that. And it is what encapsulation. It is called encapsulation. Adding these different information, different headers and trailers. Finally, in the physical layer, what it do? It converted into bits and transfer here. Data encapsulation. Now de-encapsulation, that means when it reaches the destination, first it reaches this physical layer. Oh, this is destination. So it reaches the physical layer which converts the binaries of bits to the data, and then first the data link layer will check the error with the help of CRC. If it is error, it will drop, and if it is not error, then it will remove this trailer and check the MAC addresses. If the MAC address is of the source, if the destination, then it will accept and send the rest of the packet to network layer. Network layer will get this rest of the packet, and then this network layer will check the IP source and destination. If the destination IP is right, then it will accept and it will remove this header and forward the data packet to transport layer. Now transport layer will check the data is coming from UDP or TCP. If it is UDP, no response. If it is TCP, then wait for all the packets to come, and then after all the packets are come, then it will join the packet and create it the single PDU to send the session layer managing the transportation, managing the sessions, and then it will transfer the session packet to presentation layer make sure that the data, if it is encrypted, it will decrypt. If it is compressed, then decompress, and then it will send the data based on the type of the data like TXT, AVI, MPG, GPG. It will forward the data to the application layer. Application layer will decide like, okay, if it is GPG data, I'm going to open it in image viewer. If it is a MPEG data, AVI data, video file, then I'm going to open it in video player. And the application layer's job is to open it in the proper application. And that is how your data goes from one machine to other machine. And what is the PDU? The protocol data unit contains the control information attached to the data at each layer. The information is attached to the header of the data field but can also be in end of the data field or trailer. PDUs are encapsulating by attach them to the data at each layer of the OSI reference model, and each protocol data unit has a name depending on the information each headers has. And this PDU's information is only read by the neighbor layer on the destination, and then is stripped off and the data is handed to the next layer. So on every layer you will see the PDU is created, which is going to be read on the destination side. This is what we have in OSI reference model, which is having these 7 layers, and these all layers doing their own job.